Okay, for lesson 3 of working with time, we're dealing with latitude and longitude. And really the biggest difficulty with this for a lot of people is remembering which one is which. And they kind of sound the same. But the way I was taught was that longitude are the long ones. What do I mean by the long ones? Well, if I look at a line of longitude, it goes this way around the Earth, and it doesn't matter which line of longitude I'm working on, it goes from each of them goes from the North Pole to the South Pole, and then the reverse goes back up again. So they're all long lines. But when I look at latitude goes around the Earth like a belt. So the equator is a line of latitude, and that's quite a big line quite a big line. It's the same size as all of the lines of longitude. But as I get closer to the Arctic Circle or the Antarctic Circle, my lines of latitude get shorter. So the longer ones are always long. Latitude are different lengths depending on where they are on the Earth. So if you use that basic method, that should hopefully help you out. But yeah, it's the main thing. Longitudes are measured as being either Okay, for today's lesson, we're dealing with lines of latitude and longitude, and the hardest thing for most people on this is just remembering which one of those is which. And the way I always remember it is that longitude lines are always long. So longitude lines always join the North Pole to the South Pole, or the South Pole to the North Pole, whichever way you want to look about it, but they're always the same length. Whereas lines of latitude go around the Earth like a belt. So obviously if I think of the equator, that's quite a big line because that goes all the way around the Earth. But if I think of, say, for instance, the Arctic Circle or the tropic lines, they all start to get a little bit smaller as they make their way up or down from the equator. So yeah, if you remember that longitudes are always the same length, they're always long, and the latitudes, they change in different size. Each of them then is measured, is referenced by a distance away. So our lines of latitude, which work our way from the equator either up or down, are either expressed as being so many degrees north or so many degrees south, based on the angular distance north or south of the equator. And the longitude lines are always measured either east or west of the Greenwich Meridian. Greenwich being basically a town in England where all our time is based on, and it's considered to be at 0 degrees, and everything else is a distance in degrees from there. So similar to how we do time, obviously, but there's a little bit of difference that goes on with time. So if we look at the position of Sydney here on a map, Sydney is 33 degrees south and 151 degrees east. Well, what does that mean? Well, here's our 30 degrees south line running through Australia, and you'll see that we're about 3/10 of the way down to the next line. And 151 degrees east, well, there's our 151 degrees line running through Australia, and slightly to the east of that is Sydney, so it's another 1 degree. So we can, state positions on the Earth given their coordinates based on those lines of latitude and longitude. As well as that, we can find what's called the angular distance between two cities. And the best way I find to do this is to just draw myself a bit of a timeline. Number line, not a timeline. So in this particular example, both these cities are on the same parallel of latitude. They're both 29 degrees north. So I've been asked to find the angular distance between them, and El Ayon, if that's how you say it, is 29 degrees north, 13 degrees west, and Kuwait City is 29 degrees north and 48 degrees east. So if I think of the Greenwich Meridian as being 0 degrees, I think I might have spelt that wrong, and it's very bad to read anyway, but that's okay. We have one that's 13 degrees west, which will sort of state as negative 13 essentially, or maybe we won't actually, we'll just go 13 degrees west, which is El Ayon. And we've got Kuwait City, which is 48 degrees east. So 48 degrees east of the Greenwich meridian. Now, in this particular instance, we can deal with this just like any old number line problem. We've essentially got, we want to know the difference, but we want to know the distance between the two. Well, obviously, if we started our early on, we've got to go 13 degrees just to get back to the Greenwich meridian, and then we've got to go 48 more degrees to get to Kuwait. So the angular distance is just going to be 13 plus 48 in this case. All right, and so that's going to be 61 degrees. And then moving on to the next one, we've got Sao Luis and Rio de Janeiro are both on the same line of longitude, 43 degrees west, and we want to know their angular distance between the angles of latitude. So if once again we draw ourselves a little line, with both of these are south, so if we think of 0 degrees as the equator, Sao Luis is just in front of it, so that's 3 degrees, and Rio de Janeiro is a bit further away from it, so 22 degrees. So we want to know this distance in here. So to do that, in this particular case, we'll say the angular distance is going to be 22 minus 3, because that's the gap between the two. So that's going to be 19 degrees. And that's how we do those ones. There's a HSC example here as well. So Melbourne is located at 38 degrees south, 145 degrees east, and Dubai is 24 degrees north and 55 degrees east. And this is just asking us to find the difference in longitude, so we can ignore the latitude. So remember, the longitude is the ones that run up and down the Earth, and they're the longer lines, so they go from the north to the south pole. So they're measured in east and west. So there's our lines of longitude there. All right, so what we've essentially got then is, if we think of this in terms of a number line, we've got 55 degrees east up to 145 degrees east there, so they're not crossing the equator, so I just need to know the distance between those 2 points. So essentially it's just 145 is going to be 145, take away 55, which is going to be 90 degrees, and that's how we do those. So if we have a look at the questions that have been set for this particular lesson in the text, so we're basically just looking to find the coordinates of places. We're looking to work out relative positions on the Earth and what their difference is between their latitude and their longitude. And just remember, we've got to do that thing. Think of it in terms of a number line. If I've got a city that's north of the equator and I'm comparing it to a city that's south of the equator, then I've got to add the two distances away from the equator. But if they're both on the north side or both on the south side, then it's just a difference between the two. But if you draw yourself a little number line, put the equator in the middle or the Greenwich meridian in the middle, depending on which one you're doing, and then plot the points either east or west or north or south of the equator or the Greenwich meridian, you should be fine with that. Okay, so have a crack at those questions. There will be a Zoom session on Friday where you can drop in and ask a bunch of questions if you wish, but at the moment the lessons will run like this. We'll have some video to do. You'll fill out your theory books and do your work in your workbooks and just upload that to to OneNote into your general work section, and that way I can go through that with you. And that's the end of today's lesson.